All right, so quick review, okay, of the naming rules that we've been going over here over the last couple of days here. I'm just going to pick a couple at random, all right, from this list here to review the formula rules, and then I'll pick a few at random from another sheet that has the opposite way. Okay, so if I'm looking at question number 15 here, for example, okay, if I'm going to write out the formula, the first thing I have to do is identify whether I'm dealing with an ionic compound or a molecular compound. In order to do that, I look for the presence of a what? Okay, I can look for prefixes, or I can look for the presence of what kind of element? A metal. If it has a metal in it, it's going to be ionic. If it doesn't, then it's molecular. Okay, so those are the things I need to look for. In number 15, yes, I've got prefixes. That's a dead giveaway that it's a molecular compound. Okay, and so I'm going to follow the molecular compound formula rules. I'm going to write phosphorus, and I'm going to write oxygen. Okay, and then I'm just going to go by the prefixes to figure out how many there are. Di means 2. Okay, penta means 5, and I'm done. Okay, writing the formulas for molecular compounds is pretty easy. Okay, don't have to drop and swap or do any of that kind of stuff. Okay, if I'm looking at number 17 here, okay, I'm looking at copper 2 nitrates. Copper is a metal, so this is an ionic compound. Okay, I'm going to write out the two things, copper and nitrate. Nitrate is NO3, it's a polyatomic ion. Okay. The Roman numeral tells me always which charge to put on the metal. So in this case, it's telling me this is the copper with the 2+ charge. Nitrate is always a -1. All right, so when I drop and swap, okay, I will need to put brackets around the NO3, okay, and the 2 will go over here, the 1 will go here, okay, we don't write ones, and we're done. All right, so we drop and swap. Sometimes we need to put brackets around a polyatomic ion. That would be the case there, right? So that would be about as difficult as a ionic naming problem would get, okay? You had to basically remember every single possible rule for an ionic compound in that one. Okay, if we are looking at going the other way, that is, I give you the formula and you have to come up with the name, okay? So we'll look at number 11 here first. Okay, so in number 11, what kind of compound do I have? Because that one's tricky. Okay, Ethan? Right, this is an ionic compound because ammonium, NH4, is a polyatomic ion. Okay, anytime you have a polyatomic ion, you have an ionic compound. Okay, also, ammonium is the only one on your chart that actually has a positive charge and behaves like a metal. All right, so if I'm looking at this one here, okay, I would write out ammonium and chloride. Okay, remember, writing the names for an ionic compound is relatively straightforward because I don't have to worry about prefixes or anything like that. Okay, if I had, let's say, number 19. All right, I've got nitrogen and oxygen, ionic or molecular? It's molecular. Nitrogen and oxygen are both nonmetals. Okay, so then I would have to go, all right, there's one nitrogen, so I don't need a prefix on it. There are 2 oxygens. I'm looking at nitrogen dioxide. Okay. So again, it doesn't matter which way you're going, from name to formula or formula to name. The first step is always identify whether it's ionic or molecular. Okay, then follow the appropriate rules for whatever it is. Okay, and one last one here. Okay, let's look at 36 here. Okay, so on 36, I've got nickel and I've got iodine. All right, so obviously this is an ionic compound. Okay, it's going to be nickel something iodide. All right, does nickel have more than one possible charge? Okay, what are the 2 possible charges? 2 and 3. All right, so I've got to figure out whether this is the nickel with the 2+ charge or the 3+ charge. Most likely it's going to be the 3+ charge, but I can confirm that by going, all right, every iodine is -1. and there are 3 iodines. That means there's 3 negatives. I've got to get 3 positives out of that single nickel. So yep, this is the nickel with the 3+ charge. All right, those are the things that we've got to remember. Okay, in your chemistry workbook package, okay, so I'm just going to show you how you find that again in case you've forgotten. Right. So you go into Google Classroom on your phone, find course materials, okay, and you are looking for this one here. It'll have your name beside it, say Unit 1 Chemistry Worksheet Package. Okay, it was where you had the questions for the atom the other day. Okay, click on that, and we will be working on the bottom of page 2, okay, and the top of page 3. We'll say do, let's say do 20 of these where you're doing name to formula, okay, and then move on to one where we've got formulas to names, okay, so that would start at the bottom of page 4 and go on to page 5. Try about 20 of those as well, okay. I'll put the key up on Google Classroom in the stream so you can check your answers as you go. Okay, just make sure you're trying them first and then checking the key. Okay, people get this idea that if they just look at the key and write down the answers, they're finished. Well, yes, but not finished in the good way. Finished in the bad way because you're not practicing or learning anything that way. All right. Okay, so guys, if you go to the stream now in Google Classroom, okay, you will see, oh, I don't know why only one of them is there. It's showing all of them here for me. So we got, because it has to upload. Okay. Okay, so we got all the worksheet keys right here. So you just have to kind of look at the picture to figure out which one you're working on. Okay, and the keys are right there. It is in my horrible chicken scratch a little bit, but I think you'll be able to figure it out. Okay, so you can check them as you go there.